Hi guys, in this video, so I would like to explain a question from the chapter differentiation. Actually, it's one of the interesting and a perfect question, guys, to test you. Okay, so now let us move on to the question, guys. Okay, the diagram below shows a part of the graph curve, right? Part of the curve y is equals to 2x minus 6 over x plus 2, and the straight line. Okay, and the straight line. Okay, it is given that the straight line is parallel to the tangent. Okay, this is our idea, parallel to tangent, parallel. If parallel means the gradient should be equal. Okay, who can give us gradient? That is the first thing you have to ask yourself. Who can give you gradient? Dy dx will give you gradient. Understand? So dy dx can give you gradient. So what I'm going to do now, I'm going to take this equation. I need to do a dy dx. Okay, guys, but this one in the form of u over v. You understand what I mean by u over v? So I'm going to do y equals to 2x minus 6 over x plus 2, right? So still remember, right? So this is going to be your u, and this bottom one is going to be your v. Understand? So I'm going to break them first. U is is 2x plus 6. Sorry, 2x minus 6. So I'm going to do the du dx. So it's going to be 2, right? When you differentiate this one, you're going to get 2. Okay, the second one is v. V is x plus 2. So when I differentiate, it's going to be dv dx, right? dv dx. It's going to be 1. Hope that you understand that small differentiation, guys. So this is a simple differentiation that you have to understand. So we already done, right? So you know, right, our formula of the dy dx in u over v. Yeah, I just write for you the formula. So this is a v with du dx minus u with the dv dx. So the bottom one is become v squared. Okay, guys, this is your formula of your dy dx. So just substitute. Just substitute means, so v, so this is your v. Put it here, direct v. And your du dx is, this is a 2. Everything just substitute. So you're going to get x plus 2, and your du dx is 2 minus, so u is going to be 2x minus 6 minus 6, and your dv dx is 1, right, over v square. Your v square is x plus 2. Got it? So now we're going to expand this. So I think this one you're going to get, guys. So guys, I'm doing a step by step. I never skip anything so that you can understand. So the negative have to go inside, huh? Okay, so guys, hope that you can understand this. So the 2x can cancel with the 2x over here, right? Because minus 2x is 0. So 6 plus 4 is going to be 10. So this is your answer, class. X, the differentiation. Okay, so this is your dy dx. Done. So I already take the curve equation. I already differentiate them. So once you differentiate, it's going to be gradient function. We call it gradient function. Why we call it gradient function? Because he will give you gradient. Understand? So you have to put the value of x. Okay, guys, let us move on to calculate the gradient. Okay, now this is the called gradient function, right? This is called gradient function. So you need to substitute the value of x, right? You need to put the value of x so that you will get the gradient, right? So I need the value of x. So when you go back to here, when you go back to this point, okay, so at this point, this is called x-intercept, right? You understand, right? This is called x-intercept. X-intercept, your y is 0, right? x-intercept, your y is 0. You understand, right? What I mean by y 0? So x-intercept, the y going to be 0. So what I'm going to do, I'm going to take this equation. I'm going to substitute 0 there. So you see, because your y here, the what you call the coordinate, this is a x-intercept. X-intercept, the y will be 0, right? Understand? So I'm going to substitute 0 here. I'm going to put the 0 inside this equation. So I'm going to get 0. Now 0 equals to 2x minus 6 over x plus 2. Right? So this x plus 2 need to bring over here times with the 0. So it's going to be 0, right? So you're going to have 0 equals to 2x plus 6. So bring the negative 6, bring the negative 6 over here. Bring the negative 6 over here. It's going to be 6 equals to 2x. So your x going to be 3. You understand, right, guys? You see, we already managed to get the x. So you're going to take this x. You're going to take this x, put inside here. You're going to put inside here. Why? That is called gradient function, right? So I'm going to put the dy, okay, dy dx. Actually, guys, you want to change your dy dx. Okay, never mind, I put the dy dx first. Your dy dx equals to, so 10 over, your x is 3. 3 plus 2 square. So if you put the inside the calculator class, so you're going to get 10 over 25, right? 10 over 25 is 2 over 5. So you're going to get a 2 over 5. 2 over 5. Understand, guys? This is 2 over 5. Right? Just use calculator. Okay? Okay, class, always remember your dy dx is a gradient of tangent. Understand? So, see? I already have a second information ready with me. So now what you're going to do now, guys, since this tangent and this line are parallel, since they are parallel, the gradient going to be equal. You know how to get a gradient here? So gradient always beside the x, right? You still remember the beside x is a gradient. So this gradient is 2q and the gradient of tangent is 205. So you're going to put them equal. Okay, understand? You're going to put equal. So what's going to do here is gradient of tangent is the 2q equals to 205. The 2q equals to 205. So your q will be 1 over 5. Understand? Settle. The last answer done. So the first thing you must ask yourself, okay, come, I recap again the whole question again, guys, for you. I recap again. Okay, this is your question, right? Okay, let us recap again, guys. First thing, what the question asks you is, they said this curve, the curve, right? This is curve, and the tangent at the P is parallel to this straight line. That means these two are parallel. Always remember if, okay, I put the parallel line for you here. So always remember if they are parallel, this is a parallel concept. If they are parallel, the gradient will be equal, right? Okay, fine. How to get the gradient over here at the point P? So what I have to do is gradient, always remember gradient is dy dx, right? So I take this equation of curve. I'm going to take the equation of curve. I do the dy dx until I got this answer, right? Hope that you understand this dy dx concept. Huh? Okay, I do until get this answer. And then I need to put the value of x. But the problem here, I don't have the value of x over here, right? So always remember this is an x-intercept. So x-intercept, y going to be 0. So that's why what I do, here always remember the coordinate is x 0, right? I put the 0 here, put inside this equation. See, I already put the 0 here. So I calculate until I get the value of x. So I get x is 3. So now I take this x3, I'm going to put inside this dy dx so that I can get the gradient. So I already put the 3 inside there. So I get 205. This is a gradient of tangent. So this gradient, the blue color line, the tangent of this is 205. So since both of them are parallel, so this gradient and this gradient going to be equal, right? So that's why I take the 205 equal with the 2q, because the two gradient are equal because of parallel. So I solve until I get the answer. Understand? So q is 105. Okay, guys. Thank you for watching. Have a nice day.